about chemical formula under the topic language of chemistry. Now what is a chemical formula? Let me give an example. H2O. Now this H2O is molecular formula of water. It represents one molecule of water. And it tells us that one molecule of water is made up of two atoms of hydrogen and one atom of oxygen. So this is a chemical formula of water even. So how can you define chemical formula? A chemical formula represents actual numbers of atoms of the elements present in one molecule of a compound. Okay. Now you can write chemical formula of any compound. If I write C6H12O6, this is a chemical formula of glucose. It represents one molecule of glucose. Looking at this, we can come to know that one molecule of glucose has 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen. So in this way, we can write chemical formula of any compound if you know the cation and anion along with their valency. Okay. Along with this chemical formula of a compound, you can write chemical formula of an elemental molecule also. For example, some elements can exist as a single atom independently. If I write Na or Mg, these elements, their one atom can exist independently. So their molecular formula is their symbol itself. Okay. If we are writing O2 or H2, here you see that oxygen and hydrogen, single atom cannot exist independently. So they make a molecule O2 or H2, similarly like N2Cl2. So this is their molecular formula. So in equation, we write O2 or H2 instead of O and H. Now, how to derive a chemical formula? So deriving a chemical formula, which is also called as deduce chemical formula or chemical formulae. So deduce chemical formulae. How to derive a chemical formula? If you know cations and anions along with their valencies, then you can derive a chemical formula looking at the name of the compound. For example, I will take sodium chloride. Now here sodium and this is chloride. So this is sodium ion and this is chloride ion, which is a non-metallic ion or anion. So cation is written first and anion is written later. So what are the rules to derive this? First, you have to know what is the valency of sodium and chlorine over here. Sodium is +1 and this chloride ion is -1 over here. Okay, so we will write only symbol of these cation and anion, or positive ion part and negative ion part. And on top of that, we will write magnitude of valency. Writing charge is not required. So this is 1 and this is also 1. We don't have to write +1 and -1, simply 1 and 1. Now we will see whether we can reduce it further. There is any highest common factor. Since these are 1 and 1, there won't be any further reduction. So we have these valencies are interchanged. That means valency of the anion goes to cation and valency of the cation goes to the anion in the form of subscript. So how can you write subscript? Means the number which is written on the right hand bottom. So Na1Cl1 in actual practice. But we don't have to write this 1 and 1. Instead, this will be NaCl because there is no number, means that is 1. So we don't have to write 1. So this is chemical formula of sodium chloride, that is NaCl. Similarly, second example, if you take calcium carbonate. Provided you know calcium ion with its valency and carbonate ion with its valency. So calcium is Ca, carbonate is CO3. Okay. The valency of calcium is +2 and CO3 is -2. So what we will do? We will write 2 and 2 here. We don't have to write charge. Okay. Now you see whether we can reduce it to the lowest term. Any HCF is there. So 2 and 2 can be reduced. So it will become 1 and 1. Now this is 1, this is 1. Now interchange the valencies. So this will become Ca. This 1 will come to here and this one will go here. So this formula will be CaCO3. So calcium carbonate formula is CaCO3. Now, another example. Let us take an example. Third one. Sodium sulfate. Sodium sulfate. Now here sodium is Na. Now you should know what is sulfate ion. Sulfate is SO4 2 minus. Sodium is 1, SO4 is 2. Now we cannot reduce it further. So interchange. So it will become Na. This 2 will come here. So this is called as subscript. And this 1 will go to SO4. So this will be SO4. So the formula of sodium sulfate is Na2SO4. So here you see that the number is 2. So we have to write this 2. So this is Na2SO4. Now another kind of example I will give. If you have to derive formula of lead nitrate. Lead 2 nitrate. Fourth example. Lead 2 nitrate. Lead has variable valency. It exhibits variable valency +2 and +4. So this is lead 2 nitrate. What is the formula? You have to derive from the symbol. This is lead and this is nitrate, NO3. Valency of lead is 2, already given there, and nitrate is 1. We cannot reduce them further, so interchange them. So what will happen? This will be Pb. This 1 will come to this, so we are not writing. This is NO3. Now this NO3 will get subscript 2. Already there is a number here, so we have to put a small bracket and write. So this will be the formula of lead nitrate, PbNO3 whole twice. In this way, you can derive formula of any compound provided you know cation and anion along with their valency. This is how we derive chemical formulae, which is also called as deduce chemical formulae. After writing chemical formulae, you can write chemical equation using symbols and formulae of the substances. So what is a chemical equation? So chemical equation, a chemical equation represents a chemical reaction with the help of symbols and formulae. Okay. So a chemical equation, if I write C plus O2 is equal to CO2. So this is a chemical equation which tells about the chemical reaction that carbon reacts with oxygen and forms carbon dioxide. So with the help of symbol of carbon, formula of molecule of oxygen and compound carbon dioxide, we can write this chemical reaction. So this is called chemical equation. Okay. Now what are the parts of chemical equation? Chemical equations have reactants and products. Left hand side and right hand side. And these two sides are separated by an arrow. Now the reactants are the substances which undergo chemical reaction or which participate in chemical reaction. And products are formed as a result of chemical reaction. Now if the reactants are more than one, then what we do, we separate them with help of a plus sign. Similarly, the products are separated by a plus sign. So reactant plus reactant is equal to product plus product. Okay, this is how we write chemical equation. Let us suppose we are writing, instead of symbols and formulae, we write names of the compound. Like if I write carbon plus oxygen is equal to carbon dioxide. So this is also a kind of equation which is called as word equation. So what is a word equation? A word equation is represented by writing only names of the reactants and products. We don't write symbol or formula. This is called a word equation. So if word equation is given, you have, this is called symbolic equation and this is called word equation. Okay. So if word equation is given, you should be in a position to write the symbolic equation for this. For example, another example I will take, magnesium plus oxygen is equal to magnesium oxide. What is magnesium? Magnesium is Mg plus oxygen. Now you cannot write O like this because we know that it will not exist independently. So this is a formula, molecule of oxygen equal to magnesium oxide MgO. So this is word equation converted to symbolic equation. Now after writing this, you see that the number of atoms of elements on the left hand side are not same as elements on the right hand side. That means here there is one magnesium atom, one magnesium. Here two atoms of oxygen, here only one oxygen atom is there. So this equation is not balanced. Okay. So this kind of equation which is written but not balanced is basic equation is known as skeletal equation. So this is called as skeletal equation. So when you get a word equation, first write the skeletal equation. Then you need to balance this equation. Okay. So now next we will see how to balance a chemical equation. The balancing of chemical equation, if you go step by step, then it's very easy. So first we have to write the skeletal equation or skeletal equation will be given. So we'll start with a word equation, write skeletal equation and then balance the equation. Why balancing of equation is very important? Because number of atoms on the left hand side are always equal to atoms on the right hand side. Okay. So I will give one more example of word equation, like hydrogen plus oxygen is equal to water. This is a basic simple equation, you all know this. Now what is the formula of hydrogen? You have to write H2 plus O2 is equal to H2O. This is the skeletal equation. Word equation, this is skeletal equation. Now we will balance the equation. This is left hand side and this is right hand side. Let us see the number of atoms of each element present on the left hand side and right hand side. Hydrogen, 2 atoms. Oxygen, 2 atoms. Here, hydrogen, 2 atoms and oxygen, 1 atom. So this is unbalanced. So hydrogen and hydrogen both are 2. So we don't have to change anything for hydrogen. Let us change for oxygen. Here 2 atoms of oxygen. Here 1 atom of oxygen. How can you make it? Do you have to make it also 2? How can you make it 2? To make it 2, you cannot write any number over here. A formula is fixed. You cannot put a subscript over there. Okay? You can add a number in front of the molecule and always start with the smallest number. You cannot write 1 because nothing is there, means already 1 is there. So we will start with 2. When you write 2 in front of this molecule H2O, this 2, we are writing this 2 for oxygen, but it also belongs to this hydrogen or if any other element is there. So this 2 is added up to hydrogen as well as to oxygen. So what will be the number of oxygen now? This 2. So now oxygen has become 2. Now count hydrogen. Hydrogen has become 2, 2 like this. Here 2 and the subscript, these 2 are multiplied. So 2 2s are 4. Now number of hydrogen has become 4. Now oxygen 2, 2 balanced, hydrogen 2 and 4 here. Again the balancing of hydrogen is gone. So we have to come back to the left hand side and get a way to make this hydrogen 4. How can you make it 4? Write a 2 over here. So now 2 2s are 4. Now these are the new numbers. So hydrogen 4, oxygen 2, oxygen 2. So this is a balanced chemical equation. This is how we balance a chemical equation. Okay. We will take another example of balancing a chemical equation. Now coming to word equations. If word equations are given, you have to write symbolic equation. For that you should know to deduce formulae. And to deduce formulae, you have to know formula and valency of ions or radicals. So another example I am giving for balancing of equation. For example, zinc combines with HCl and forms zinc chloride and hydrogen gas is liberated. Okay. Zn plus HCl is equal to ZnCl2 plus H2. Now let us see, this is a skeletal equation. Sometimes the given equation is already balanced and you have to write it as self-balanced. Okay. When you are balancing, always start using a pencil and finally you write the correct equation. So here left hand side and right hand side. Zinc, Zn. What are all the elements there? First write down Zn, only 1, Cl, 1, H, 1. On the right hand side, Z, same sequence you write, Zn, 1, Cl, 2, hydrogen also 2. So now you check. Always we start balancing with metal. Then we go to non-metal. So the first preference is given to metal. Now zinc is a metal. Look at zinc. 1 and 1. So both the sides it is balanced. Then go to Cl. Here 1 Cl, here 2 Cl. So we have to make it 2. To make it 2, we can write a 2 over here. So what happened here? This has become 2 now. It has become 2. Along with that, this hydrogen has also become 2. So this will also change to 2. Now let us see whether it is balanced. Zn1, Zn1 done. Cl2, Cl2, H2 and H2. So the equation is balanced. This is how you have to balance the equation. If you are writing 2 or 3, then it is not getting balanced. Then you can change the number, but finally you write the correct equation. Okay, next we will see law of conservation of mass. Now what is law of conservation of mass? Matter can neither be created. According to law of conservation of mass, matter can neither be created nor be destroyed. Okay, it only changes its form. So total mass of the reactants will always be equal to total mass of product. That is why we balance the chemical equation. Okay, so let us take an example. Ca plus HCl is equal to CaCl2 plus H2. Now here calcium plus hydrochloric acid, calcium chloride and hydrogen. Now look at this equation. This equation is unbalanced. So first we have to balance the equation. So 2, then it will get balanced. So hydrogen 2, calcium 1, chlorine 2. Now what is mass of, we have to calculate individual mass of each reactant, like mass of calcium, then mass of HCl, this and this. Then we will see total mass of reactant and total mass of product. So what is mass of a compound? If you know the atomic masses, you can calculate total mass, molecular mass. So molecular mass. So calcium can exist as a single atom. So its mass is 40. Okay. So 40 is atomic mass of calcium. So you write 40 over here. So you can write this mass with grams, then it will be called as gram atomic mass. So this is 40. Now HCl. How many molecules? 2 molecules are there. So we will take this 2 and inside the bracket we will write 1 HCl. So what is atomic mass of H? 1 plus Cl is 35.5. Now here calcium. Calcium is 40 plus 2 chlorine atoms are there. So 2 into 35.5, keep it in a bracket. And here 2 atoms of hydrogen, 2 atoms of hydrogen, 2 into 1. So this will be molecular mass of H2. So let us see, this 40 will come 40. Now here 35.5 plus 1 will become 36.5. So 2 into 36.5 will come 73. Okay. Now here, and this equal, this is left hand side and this is right hand side. Now here you see this is 40 plus, how much is this? 35.5. Okay, so this will be 71 and this is 2. So this will be total 111. So here 40 and 73. So total will come how much? 3113. Here also comes 113. So this is total mass, reactant, product. So total mass of reactant is equal to total mass of product. So what is total mass of reactant here? 113. Total mass of product is also 113. So this is what the total mass of the reactant is equal to total mass of product. That is law of conservation of mass. So only balanced chemical equation obeys this law. So you have to balance the chemical equation. So this is one example. On this you can solve some numericals also. Now let us see what all the information given by chemical equation. So next is information given by chemical equation. What are the informations you get from chemical equation? As we wrote, Ca plus 2HCl is equal to CaCl2 plus H2. Total mass 113. This is also 113. Okay, here 1 molecule, 2 molecule, 1 molecule, 1 molecule. Now what are the information a chemical equation, balanced chemical equation gives us? The first one, it tells us what all the reactants and what all the products there in this chemical reaction. So names or information about, tells about reactants and products. What all the reactants and products involved in the chemical reaction. Second, it tells us about symbols and formulae of the reactants and products. So symbols and formulae of the reactants, symbols and formulae of the products. This is the second information you get, symbols and formulae. What is the third thing you are getting from this is the mass ratio. What is the ratio? Okay, so now you see this is 1 and this is 2. So the left hand side ratio is 1:2 and the right hand side is 1:1. So in which ratio the reactants and products are existing in this chemical reaction, or the ratio between the reactants and ratio between the products. What else we come to know from this? Atomic masses or molecular masses. So total mass of the reactant and total mass of the product can also be achieved from looking at the chemical reaction. So these all the informations given by a balanced chemical equation. Okay, but still this equation has some limitations. If you write a chemical equation in balanced form, then also it has some limitations. What are the limitations? Limitations of a chemical equation. First of all, this chemical equation, looking at this chemical equation, you will not come to know state of the matter. What is the state of matter? Nothing is given over here, whether it is a solid, liquid or gas. So it doesn't tell about state of matter. Next, information gathered from a chemical equation. What all the information you get from a balanced chemical equation? Now look at the same equation. Calcium plus hydrochloric acid, Ca plus 2HCl is equal to CaCl2 plus H2. Now left hand side and right hand side. What all the information you get? You get names of the reactants and products, like this is calcium, this is hydrochloric acid, calcium chloride and hydrogen gas. Symbols and formulae of each reactant and each product. This is Ca, HCl, CaCl2 and H2. The number of atoms or molecules of each reactant taking part and each product formed. One unit, one, or you can say one molecule also, one atom or one molecule. Here two molecules, since 2 is written here, one molecule and one molecule. So the ratio of molecules, so the ratio, if you see, this is 1:2, 1 and 2, this is 1:2 taking part in chemical reaction. Then mass of the reactant and mass of the product, as you found it, the total mass is 113, that is equal to 113. This is all the information you get from a balanced chemical equation. Next, limitations of a chemical equation. Okay, so what are all the limitations we face? If you write this equation, Ca plus 2HCl is equal to CaCl2 plus H2, the first thing which this chemical equation doesn't tell about is state of these reactants and product. You doesn't know that whether the reactant is a solid or liquid or gas, and same with product. Okay, nothing is mentioned over here. So state cannot be found. The second problem with this is it doesn't tell whether the chemical reaction is completed or not. The third thing is it doesn't tell speed of the reaction. Some reactions are very fast, some are very slow and some are moderate. So you cannot make out, looking at the chemical equation, whether the reaction is fast, slow or moderate. Another problem with this balanced chemical equation is that it doesn't tell whether any special conditions are needed, like any catalyst is used or any pressure, temperature, light is required, heat is required, electricity is required. And the last one is that it doesn't tell whether the color is changing from the reactant to the product, any precipitate is formed or heat is evolved, light is evolved or any sound is produced during this reaction. So these are the limitations. So how to overcome these limitations? To overcome these limitations, we can write all, like another example I will give. Nitrogen combines with hydrogen and forms ammonia. Okay, so reversible sign if you put, we come to know whether it is reversible or not reversible. Now here we can write G, G and G. This tells about state. This is gas and this is also gas. We can write if any catalyst is there. Here the catalyst used is iron and the molybdenum is used as promoter, so we can write. So looking at that, we come to know this is catalyst and this is promoter. Another thing, temperature conditions can be mentioned this way: 450 to 500 degrees. Pressure 200 to 900 atmosphere. And here we can write plus heat. So in this way we can make some changes to make it more informative. So looking at this, we can come to know the state. We can come to know that the reaction is reversible, the catalyst, the promoter, the temperature condition, pressure condition, and the equation is exothermic equation. So this is how we can make slight change in chemical equation. Let us solve some numericals on calculating molecular mass of a compound. Okay. So before starting any numerical, once again to see how to calculate molecular mass of a compound, if you know the atomic masses. Okay. So if we are calculating molecular mass of, let us suppose take example water. This is made of 2 atoms of hydrogen, 1 atom of oxygen. Now atomic mass of hydrogen is 1. So how many are there here? 2. So 1 into 2. So total it will come 2. It will come 2 plus atomic mass of oxygen is 16. So it comes 18. So this is molecular mass of water. For numerical calculation, we write g grams over here to mention that mass, the weight of the substance taken. So we will apply this and solve some numericals. Let us see this numerical. Calculate the amount of lime. What is lime here? Calcium oxide formed when 50 grams of calcium carbonate is heated. Okay, this is the question. 50 grams of calcium carbonate is taken and heated. So it will break down into calcium oxide. This is lime and carbon dioxide. So how much lime or calcium oxide is produced by 50 grams of calcium carbonate is the task. Okay. So for solving that, we have to take a standard equation and standard value. Now atomic masses are given over here. Calcium 40, oxygen 16, carbon is 12. Okay. So let us calculate molecular mass of reactant and product. Here we are talking about calcium carbonate and lime. So you can calculate only masses of these two. This is not mentioned in the question. So if you don't calculate also, it's okay, because it is not applicable over here. So calcium carbonate, how to calculate? Calcium plus carbon plus 3 atoms of oxygen. So calcium is 40 plus carbon 12. 3 oxygen are there and 1 oxygen is 16. So 16 3s are 48. You can write directly like this. So it will come all together 100 grams calcium carbonate. Standard equation, if you write the molecular mass of calcium carbonate is 100, which is gram molecular mass 100 grams. Now calcium oxide here 40 plus 16 will come 56. So mass of calcium oxide is 56. So this balanced chemical equation says that if 100 grams of calcium carbonate is heated, it gives 6 grams of calcium oxide or lime. And our task is what happens when we heat 50 grams of calcium carbonate. Okay. So we will write statement for this. 100 grams of calcium carbonate forms 56 grams of calcium oxide. Therefore, 50 grams of CaCO3 will form how much? 56 into 50 upon 100. Cross multiplication. Okay. So now this 0, 0 cancelled, 5 1s are, 5 2s are, or 50 1s are, 50 2s are, anyhow you can do. So 2 1s are here, 2 2s are and 2 8s are. So it comes 28 grams. So 50 grams will give 28 grams of calcium oxide. This is how to calculate. Okay, second numerical is calculate the amount of magnesium oxide formed when 60 grams of magnesium is burnt in air. So when you take magnesium and burn it in air, it will combine with oxygen and form magnesium oxide. So 60 grams of magnesium is given, and how much magnesium oxide can be produced by burning this 60 grams is the task. So first step is to write the equation. First write the skeletal equation. Magnesium plus oxygen gives magnesium oxide. And then on heating, you have to balance the chemical equation. So balancing the chemical equation, here 2 oxygen are there, here only 1 oxygen. So we will write a 2 over here. Now oxygen is balanced. 2 magnesium, only 1 magnesium. So write a 2 over here. Now this is a balanced chemical equation. Now let us see according to this equation what is the mass of magnesium oxide produced. So let us calculate molecular mass of reactant and product. So magnesium, 2 atoms are there, and magnesium is 24 atomic mass, oxygen atomic mass is 16. So 2 into 24 will give you 48 grams. Here oxygen 2 into 16, and this will give 32 grams. And here 2 in bracket 24 plus 16. So 24 plus 16 is 40. So 2 into 40 gives 80 grams. Now here it tells us that 48 grams of magnesium combines with 32 grams of oxygen when heated forms 80 grams of magnesium oxide. Now let us see if 60 grams of magnesium is burnt, then how much magnesium oxide is produced. So write the statement. When 48 grams of magnesium forms 80 grams magnesium oxide. Therefore, if 48 grams, therefore 60 grams of magnesium forms how much magnesium oxide? So this is 80 into 60 divided by 48. Cross multiplication. Now we will solve this. 60, so this is 6 ones are and 10s are. 6 8s are 48. Now 8 ones are 8 and 8 10s are 18. So 10 into 10 will give you 100 grams. So this is the answer. 100 grams of magnesium oxide. So you have to write 60 grams of magnesium when burnt in air gives 100 grams of magnesium oxide. This is how you have to solve the sum.